Welcome back. In this particular video, I want to give you the overall approach or strategy we use to organize the chemical content in the video series, and also identify the guiding philosophy followed in the construction of the videos. There are many ways to approach the different topics in chemistry. There is a traditional and somewhat holistic approach where we describe the chemical reactions as quickly as possible and then build the atomic and molecular reasoning behind the processes a bit later. I learned my chemistry this way, and it does have the advantage of allowing us actually to see and use chemical reactions earlier in our studies. Another approach is called the atoms first approach, in which we build our chemistry by understanding the atomic structure and then work up to elements and compounds and finally chemical processes. It's a very logical and straightforward approach, and I like it. But after my many years of teaching and doing chemistry, I found that my narrative of chemistry doesn't easily fall into either of these approaches. Furthermore, I'm cursed. I'm a physical chemist, and we physical chemists tend to look at chemistry through the lenses of physics and mathematics. There's no way to get around it. This will color my presentation of the chemistry somewhat. So let's look at my slightly different way of looking at chemistry. Back in the day, I was once a building contractor, and I still tend to think about projects, such as building a structure for learning chemistry, as if I was building a strong house. We start by digging deep into the ground and putting in a robust foundation with a floor that can hold everything up. Once the foundation is in place, we construct the load-bearing walls that keep the house upright and stout. We then cover the structure and place upon the walls a well-constructed roof. These three elements, the foundation, load-bearing walls and columns, and the outside cover and roof, form the most critical parts of the structure. Once these things are in place, we can fill in all the gaps with the housey parts, the elements and little details that make the house functional. The foundation of our chemistry house is the fundamental knowledge and skills needed before we synthesize the higher level chemical information. For chemistry, this foundational knowledge is the mathematics we need to do quantitative work, the physics principles that help us make sense of the natural world, the measurements we use to analyze, quantify, and probe the chemical world, the problem-solving strategies we utilize to guide us in our understanding of chemistry and chemical problems, and finally, the symbolic representations and nomenclature that we must master if we want to understand and communicate chemical knowledge to one another. As we build and understand more and more chemistry, this foundation will have to grow to accommodate it. One of the load-bearing walls that hold up our chemistry is the microscopic knowledge of matter centered about the physics of the quantum world. At this level of knowledge, we describe the nature and properties of atoms which form the elements on the periodic table and identify how these properties govern the interactions between atoms to form chemical bonds and molecular structures. The other wall is the macroscopic knowledge of matter. Here, we focus on describing the bulk system using properties we can readily measure. It is at this level of knowledge where we describe the fundamental thermodynamic and kinetic principles that guide the changes we see in a bulk system. Thermodynamics is the study of heat, work, energy, and the changes they produce in the state of the systems. Kinetics is the study of the rates of reactions and production of mechanisms that describe actually how a reaction runs. Now we put on the cover and the roof and all the functional parts. You can see that it's at this point that the house finally starts looking like a house. The cover and the roof in my description is simply the changes that matter undergoes. We further categorize each of these changes as either physical, chemical, or nuclear. It's these changes that make chemistry functional and an important central science. We define a physical change as a process that does not change the chemical composition or the elements of the matter. Some examples of these kinds of changes include processes such as tearing or molding a substance, heating or cooling of matter, changes of physical state of matter such as melting or boiling. We also will include dissolving something like salt in water as a physical change, since strong chemical bonds are not formed between the water and the salt elements, and it's easy enough to kind of get the salt back by simply boiling off the water. We define chemical changes as processes where there are changes in the chemical composition of the matter, but not the elements of the matter. Here, chemical bonds are broken between elements and new ones are made. Such changes include combustions, rotting and decompositions, rusting, and cooking. Chemical changes can be categorized as precipitation, acid-base, and oxidation-reduction reactions. Be aware that many changes in a lab can involve a complicated mixture of chemical and physical changes, okay? Now, finally, we define nuclear changes as processes that change the elements of matter by changing the nucleus of the atoms. The emission of particles by radioactive elements, fusion and fission are the more classic examples of these types of changes. You can see from this type of chemistry structure that we are not going to learn chemistry linearly, but in a more layered fashion. This hopefully will allow for an array of possible topical studies, making the series relevant to you whether you're trying to learn introductory chemistry, work on a specific topic, or if you're trying to review and looking at chemistry at a more advanced level. And I admit it frankly makes it easier for me to add additional content to the series as new videos are produced. At the start of each video, after the title, you'll see a content slide. We'll try to identify the part of the structure the content most closely aligns and identify other videos in the series that form foundational and needed content in understanding this current video. Such an endeavor is fraught with possible and more than likely probable flaws and errors in judgment. So I'm begging your forgiveness before we even get started. Clearly categorizing a chemical topic is hard, and I'm sure I'm going to overestimate or underestimate what's needed for understanding each topic. But I hope that I'm at least giving you some storyline or narrative that you can use to organize each piece of chemistry content and knowledge you learn. All right, let's dive in and see what happens, okay? Catch you later.